Welcome you all to my YouTube channel. This is Rwanda Gamak. Allow me to share my screen with you. Mm, so my AI problem is the use of AI at the university examination entrance. So the contents of presentation are the problem statement that are said to be used, factors considering choosing the dataset, important features of the dataset, Bayesian theorem, naive Bayes, Bayes network, differences between Bayesian theorem and naive Bayes, differences between naive Bayes and Bayesian networks, references. So the use of paper document at the entrance of the examination rooms is a problem statement. There is currently a problem of students accessing the examination room even without fully paying the tuition dues. And this is because the student portal can easily be hacked to generate the examination permits, and also sometimes, actually, this can be seen previously in the last semester where students were able to hack the student portal and they were able to generate a payment, they were able to generate an examination permit, and they were able to sit for the examinations, which at times was unfair. That means it's also it's also possible for a student to impersonate and then the student impersonate and someone else does for them their paper. So the data set to be used in solving the above problem is from GitHub. It's the data set is attendance system with face recognition. So particularly, this dataset is going to help us to recognize students who are fully eligible to sit for the examination through identifying those who fully paid tuition and those who didn't, and also at the same time identify students and non-students. This will help to reduce the impersonation rates. This is going to be through when it connects to the database, so it should be able to identify this that you're a student and then you're eligible to sit for the paper, and you're a student or you're not eligible to sit for the paper. So this can also solve the problem of missing examination marks for students, since the students who sit for the examination will be registered. So apparently, some lecturers misplace papers. So by the time the results are released, they are missing marks. So this can also help out, since it can be able to show that the students sat for the paper, meaning that maybe they didn't get out of the examination room with their paper. And also, factors considered when choosing the AI attendance system with best recognition were it has a dataset creation module where a system can collect images of new students. Yeah, because not every time we're going to be having the same students at the university. New students will be registered in the coming intake, so this is going to help the data to be flexible. So unauthorized the students detection and prevention from access to the examination. So once they identifies that you're not a student, the invigilator or the lecturer should tell you to step aside, and then the students who fully paid or who are the students, they should be able to enter. So no need of student aid, since the system can use biometrics. So why would a student who is a registered why would a student carry an exam why would they carry an examination permit and a student's ID as the system is going to show? So this will help to remove the problem of all those paper documents. So the ease of the software to update tuition default as non students with the students first using computer vision. So it's very easy to update the system with the data in the database. The important features in an AI attendance system with face recognition, ability detection, and face detection. Insert students. This should be able to insert new students into the system, then edit student data. So if some students have a retake, that means they are eligible. If they pay for the retake, that means they should be able to sit for that paper to reduce. That means the student data has been edited. So create a data set of students' faces. So different students have different faces. We all don't have the same faces. So that means it should be able to identify the students, then train AI model with a single click. So once you look, it should be able to show that you have done you're a student who has fully paid the tuition or not. So without should not over you should look once, then gives you the details, and then we're going to look at the Bayesian theorem. So it's a method to determine conditional probabilities defined by the formula below. Then probability of A given B equals to probability of B given A times probability of A divided by the probability of B. It's the Bayesian theorem equation. The probability of A given B is the posterior, probability of B given A is the likelihood, probability of A is the prior probability, probability of B is the prior probability of evidence. A is called the proposition, B is called the evidence. So the Bayesian theorem is continued. So this theorem assumes that each input variable is dependent upon all the other variables. So the algorithm is used to provide results comparable to other algorithms. It's only used with assumption of class condition independence is mainly used in classification problems. So apparently, this this Bayesian theorem, is aimed at. So apparently, this Bayesian theorem majorly depends for it shows that for a certain condition to be fulfilled, the condition must have been fulfilled already. So for example, if you wake up and you take tea, that means for you to take tea, you have to first wake up and then take tea. So A, so here B can be the that you have woken up, then also A can be that you have taken tea. So it is probability that you have taken tea given that you have already woken up. And probability of B given A is the same as like probability that you have woken up given that you have taken tea. Then times probability of that you have taken tea divided by probability that you have already woken up. So then also we have the naive Bayes. So it's a classification technique based on the Bayes theorem with any assumption of independence among predictors. So types of naive Bayes include Gaussian, which is used in distribution, multinomial, which is used in discrete, but only used in feature vectors where they are binary. So it's easily used where there is inadequate time to fully develop the model. It's used in large data sets, used to outperform highly sophisticated classification methods, provides zero calculating posterior probability. From their formula, they are all related. So the naive Bayes generally for it, for it, it's used or I'm going to, so it's easily used where there is inadequate time to fully develop the model. So in case you don't have enough time to get all the data and then develop the model, so this theorem is going to work out like for now we are going to be dealing with a student data. Different students have different student numbers. So I mean different students have different faces. So it's going to help us that how we assume like we have taken College of Computing. So College of Computing has so very many students. For example, it has students in the College of Computing sector. There is there one, there is there two, here three. They all have different faces. So right now it may not be possible in the shortest in this semester to collect all that data. So we're going to be so the naive Bayes will help us out. So that's why they say it's used in large data sets. Then also the naive Bayes, how the naive Bayes works is that you convert the data set into a frequency table. That means you have been given the data, you convert it into a frequency table, create a likelihood table by finding the probabilities, use Bayesian equation to calculate use Bayesian equation to calculate the posterior probability for each class. Then applications of the naive Bayes include it is used in real-time prediction, used in multi-class prediction, used in text classification, used in recommendation system. And the Bayes network is also, I'm going to take it in the Bayes networks. So it's a type of graphical model that uses probabilities to determine the occurrence of an event. It's also known as the belief or causal network. It consists of directed cyclic graphs and a table of conditional probabilities. Probability table shows likelihood that a random variable will take on certain values. An example of a cyclic graph is shown below. That means if we have events A, B, C, and D, so B can be taken as the parent node and A can be taken as the B is the parent node. So A and D are the students. So A and D are like the children to the parent node of B. So first, excuse me for some few minutes. Sorry for the inconvenience. Then we have the Bayes networks. So it's contains types of Bayes networks and a giant probability. This is where two or more events are happening together. Conditional probability. This is where one condition takes place given the other condition are taking place. Actually, conditional probabilities is like the Bayes theorem. So application of applications of Bayes networks, spam filtering, biomonitoring, information retrieval, image processing, and so on. So the differences between Bayesian theorem and naive Bayes, the Bayesian theorem assumes that each input variable is dependent upon all other variables. Then also the naive Bayes assumes conditional independence. So a Bayesian theorem is a theorem. Naive Bayes is a classifier. Bayesian theorem is interpreted as decision rule. So naive Bayes is an approximation to the Bayes classifier. And then also the difference between naive Bayes and Bayesian networks. So naive Bayes, the classification technique based on Bayes theorem with an assumption of independence among predictors, and Bayes networks is a type of graphical model that uses probability to determine the occurrence of an event. Um, these are the references. So we have come to the end of my YouTube presentation. So please help me and like and share my content. Thank you for your time.